Okay, now let us continue with question 8. In question 8, we are required to determine f prime of x from first principle. And we are given the function f at x, and we are given 5 marks. So solution to this case, 8.1. So remember, you will be given this formula f prime of x being equal to a limit as x tends to 0 of f into x plus h minus f at x all over h. So this one will be given to you in a formula sheet. And if you want to solve it exactly as it is, you can solve it like this. But if you feel like maybe it might confuse you, start by writing f at x plus h separate. So whenever you see x, you plug x plus h. So in this case, we have 3 into x plus h because we have x here. Squared minus 2, of which is equal to 3 into x squared plus 2xh plus h squared minus 2 is equal to, now you have 3x squared plus 6xh plus 3h squared minus 2. Okay, here whenever you are solving this, you have to know the rules of differentiation so that whenever you solve, you will see if you got the right answer or the wrong answer. But let us continue with this one. And the function f of x here is equal to 3x squared minus 2. Okay, so now from first principle, you now write your first principle is equal to a limit as h approaches 0. What is the value of f at x plus h? F at x plus h is represented by this function now, which is what? Is 3x squared minus 6x h plus 3h squared minus 2. Close bracket minus something. What is f at x? It is 3x squared minus 2. Then we divide this by what? By h. Okay, then you have f prime of x that is equal to a limit as h approaches 0. So now you want to remove the bracket throughout. So you have 3x squared minus 6xh plus 3h squared minus 2 minus, so here we're multiplying, you want to get rid of this bracket, so we'll end up with minus 3x squared, this one times this one to plus what? Plus 2. Then you divide by what? By h. Okay, then from the f prime of x will then be equal to a limit as h approaches 0. So look carefully now. This one and this one goes off again. Minus 2 and 2 goes off. So what you are remaining with now, you are remaining with 3h squared. No, it was plus. It was plus. Apologies. It was plus here because you see it's plus, not minus. So plus 6xh. Okay, so this is what we have over what? Over h. The rest gone. So what do you see that is common here? You can see that we have a common factor that we want to factor out, of which is h in this case, into 3h plus 6x divided by what? By h. And then again these two divides one another, then you are now left with what? With a limit as h approaches 0, of which is 3h plus 6x, still working with f prime of x. Now you can then let your h be 0 now. So if you let h be 0, you end up with 3 times what? 0 plus 6x. So 3 times 0 is 0 plus 6x. So the final answer is what? 6x. So f prime of x is equal to 6x. Okay, so you see here, you used a first principle rule, but before even using first principle rule, you can just use rules of differentiation. What are the rules of differentiation says? They say that when you are differentiating 3x squared minus 2, what you do, you say, okay, here in this case it's mx n. So you say m times, so you multiply the coefficient of x by the exponent, and on the very same exponent subtract 1. So in this case, the coefficient is what? Of m is what is now is 3. So it's 3, the exponent in this case, because it's a coefficient and exponent. So the coefficient here is 3 and the exponent here is 2. So to multiply by what? By 2. And then you have x, and then on the exponent you subtract what? 1. Minus what? If you can look carefully here, in this case, you have something like this. I just want you to understand why the differentiation of the constant is 0. It's because you have here, you have 2x to the power of 0. Now you see that one. So when you, because you know that any power to the power of 0, any power that has a base that has an exponent of 0 is equal to 1. So in this case, this is same as what now? 3 times 2, it's 6x, and then 2 minus 1 is what? Is 1. Minus what? In this case, you'll be having 2 times what? 0x, 0 minus 1. So you see, whatever that you multiply by 0 give you what? Give you 0. So that as a result, that is why we have something like this. We have 6x minus 0, of which is 6x. That is why f prime of x, or that is why whenever we talk of f prime of x of a constant is equal to 0, it's because of this. When you apply rules of differentiation, you tend to find out that any multiple of 0 is 0. Okay, so the second question requires us to use the rules of differentiation. So I'm required to determine data y over data x if y is equal to 2 to the power 2x to the power of minus 4 minus x over 5. So here it's 8.2, they say. Required to find a data y over data x if y is 2x to the power of minus 4 minus x over 5. Minus x over 5. So now when I want to find data y over data x, I'll be saying dy over dx is equal to, you multiply this one by an exponent x, and then on the exponent you subtract what? Subtract 1 minus. So look carefully here, this one is a fraction of 1 over 5 times 1x, of which is 1 by minus 1 now. So this is how you differentiate this. And here you end up with minus 8x to the power of minus 5. And then here, you look carefully here, minus, it will be 1 over 5x to the power of 1 minus 1, of which is 1 over 5 x to the power of 0. As a result, you have minus 8x to the power of minus 5 minus 1 over 5. But I can advise that you don't leave your exponent as negative. So you can leave this as what? Can leave it as minus 8 over x to the power of 5 minus 1 over 5. So yeah, that's how you can use the rules of differentiation in order to solve for this. But since you are given your equation in terms of powers with the negative exponent, you can also leave it like this. They won't penalize you for that. No, in fact, like this, because now you've completed everything. They won't penalize you for that, but for simplicity, we have to try by all means to refrain from leaving negative exponents. I hope I was clear on this question.